Hello students, today coming with a new question from 2024 paper, a different type of question. Paper code 5511, question number 18. A and B was the two was the question. A monochromatic light of frequency 5 into 10 raised to 14 Hertz passes from air into medium of refractive index 1.5. Find the wavelength of the light, we want to calculate, of reflected light and refracted at the interface of the two media. So what we want to calculate is wavelength of refracted and reflected. Okay. It is like a glass lab experiment. Usually when we do the glass lab experiment, we drew only this one, the refracted light. But actually you know that partial reflection and refraction going on. So first we can write what are the things given here. Frequency given. So nu is equal to 5 into 10 raised to 14 Hertz. Okay. And the refractive index of the medium is given, that is from air entering into the medium, right? That is 1.5. Now speed of light in air, even not given, you have to write. That is equal to 3 into 10 raised to 8 meter per second. So this much we can write easily. Now we can draw a ray entering into the glass slab. Not glass slab, any medium of refractive index 1.5. And now undergoes partial reflection. So marked here the reflected ray, and also undergoes refraction, refracted ray also marked. Label also we are putting now. So this one we can say reflected, correct? Reflected. And which passes through, that is refracted ray. Okay, that is done. Now we can start the solution. Before that, let me share some important points, important notes with you related to this one. Okay, what is the first point I want to share is, out of three quantity, velocity, wavelength and frequency of a wave, one of the quantity never change when a light move from or wave travel from medium to medium. So first point is frequency of light never changes when it goes from one medium to another medium. Remember that one. This we saw in the derivation where, verify Snell's law using Huygens principle. At the end of that derivation, this point was there. Second thing, wavelength, even speed, wavelength or speed both, will changes. Okay, wavelength changes because wavelength is linked with the relation speed. Because of speed changes, wavelength also changes. Okay, that are the 2 points I want to share first. Then we can enter into the answer part. There are 2 questions, right? Wavelength of reflected, wavelength of refracted light. So this is the question we are going to solve, wavelength of reflected light. So wavelength of reflected light, when light is reflected at the boundary, remember the image first, okay, what I drew before. Incident ray and the reflected ray both are in the same medium, that is air medium. So because of they are in the air medium, there is no change in the speed of light. Because of no change in the speed of light, no change in the velocity of light. Wavelength of light. So it stays in the same medium. So lambda air is equal to C by nu is equal to C. 3 into 10 raised to 8 divided by nu. 5 into 10 raised to 14. So division of 3 by 5 will be 0.6. 10 raised to exponents rule apply. From denominator 14 coming, so minus 14. So 8 minus 14, that is minus 6. Then shift 1 point. So 0.6 write as 6 into 10 raised to minus 7. Okay. One more adjustment we do to get the answer in nanometer. So make it 600. So 2 point extra moved. So 10 raised to minus 2 have to use. So 10 raised to minus 2 into 10 raised to minus 7 already there. So total 10 raised to minus 7. So 600 into 10 raised to minus 7, we can say 600 nanometer. So lambda air calculation done. That means wavelength of the reflected light calculated. Wavelength of the reflected light calculated. Simple procedure, right? Now we work on wavelength of the refracted light. Remember, during refraction, the ray is in the second medium after refraction. So there will be a speed change, there will be a wavelength change. So inside medium, of refractive index n is equal to 1.5, it is given in the question. We can write speed of light. Okay, it increase or decrease? Definitely it decreases, because the fastest in the air medium compared to the surrounding medium. So speed of light becomes n is equal to c divided by v. The first expression you studied in grade 10, refractive index. So nu is equal to c by n, cross multiplied. So 3 into 10 raised to 8 divided by n, 1.5 is equal to 3 by 1.5 is 2. So 2 into 10 raised to 8. Got it? Yeah. Speed found now. If you know the speed, you can find the wavelength now using the expression lambda medium is equal to v by nu. Remember, v is actually c place. 2 into 10 raised to 8 divided by 5 into 10 raised to 14. Other way also you can do the same answer. I like this way. This is easy way. So lambda medium is equal to divide 2 by 5 is 0.4 into 10 raised to 8 minus 14, because 14 coming from downside. So 0.4 into 10 raised to minus 6. Now shift 1 point first. So 4 into 10 raised to will come, and 4 into 10 raised to minus 7, simple step I write. 4 into 10 raised to minus 1, that is minus 7 total. Okay, 0.4 into 10 raised to minus 6 is 4 into 10 raised to minus 7. Now we want to write this one in the nanometer format. So 2 more points shifted, so 10 raised to minus 2 came, so total 10 raised to minus 7 and minus 2, so total minus 9. So 400 into 10 raised to minus 9 meaning is 400 nanometer. Understood? Yeah, 400 nanometer. Now we found the wavelength of reflected and refracted. How is this one? What do you feel? If you understood, please post a comment, like at least a thank you. I will bring more numerical, which will give you more confidence in the upcoming examination. Okay. If you like the video, please like the video, and if you want to explain, if you want any explanation for numerical, please post your question in the comment box. Okay, and try to watch the channel every day. Most of the day I will be posting. Okay, thank you for watching. Have a nice day. Waiting for next video. Thank you. Cut.